Hello everyone. Now let us move on to the next experiment, that is experiment number 11, Newton's law of cooling. So the title of the experiment says that we are doing something related to heat. To begin with, before going into any details written on the board, I'll just show here. See, in this vessel I have some hot water, and now I want to record the rate at which this hot water cools down. So, is it possible right now without using any other instrument? Is it possible to sit in front of this and make sure that it is losing heat only in one direction or something and record the readings? No. So, to perform such an experiment, we need a special type of device called the calorimeter. Okay, so now let us go back to the board and see what do we have here. See, the aim of the experiment is to study the relationship between temperature of a hot body and time. Okay, so the main aim of today's experiment is to record the relation between the temperature and time. Okay. And our title says Newton's law of cooling. So what is this Newton's law of cooling? This is a statement given by Newton which gives the information about the rate of cooling of a body. And the statement is the rate at which a body loses its heat is directly proportional to the difference in temperature between the hot body and its surroundings. Okay, I'll give a very simple example to understand this statement. Suppose you have a hot cup of coffee or a hot cup of water. Have you ever noticed the time at which the hot coffee or hot water becomes warm and the warm water or coffee comes to room temperature? So, if you ever notice, you can say that the rate at which the hot body becomes a warm body is much quicker than the later case. That is because the rate at which a body cools down is directly proportional to the temperature difference between the hot body and its surroundings. Now let us move on to the experimental part. So to perform this experiment, we need a calorimeter with a lid and water, thermometer and a stop clock. This is the experimental diagram of what I have shown here. Okay, so this is the calorimeter setup, this is the stirrer, this is the thermometer. Okay, and coming to the observation part, to begin the experiment, first we have to record the laboratory temperature, which is denoted by theta naught. Next, we have a tabular column here wherein we will fill the data, okay, of the experiment that we perform. And sorry, here the table is written in a very small table is shown here because I had to write down these two graphs over here. And don't think that only one or two trials is enough to perform this experiment. Since it's a graphical experiment, to reduce the error, readings has to be taken for more number of trials. Minimum of 6 trials is required. So first is the trial number, next is the temperature, then time, then excess temperature, and last one is log to the base 10 of this excess temperature. So basically what are we doing in this experiment? See, this is the calorimeter. I'll open this. Okay, inside this I have a cylindrical vessel which is made up of copper, and this is a stirrer. This is also made up of copper. I'm going to pour this hot water and then I'll close this lid and I'll fix the thermometer here. Now, what are we going to do? As I told, initially we'll record the laboratory temperature, then we will record the temperature of the liquid, and then we'll go on recording the time taken by this liquid to lose its temperature in steps of 2 degrees centigrade. So, starting with some 70 or 75 degree, we will record this up to some 6 trials in a difference of 2 degrees centigrade each. Once we are done with the tabular column, next we will have to plot 2 graphs in this. One graph, as you can see here, temperature is taken along the y-axis and time is taken along the x-axis, and this is the curve. As you can see, it is exponential curve which is called cooling curve, and in the next graph we have log to the base 10 of theta minus theta naught along the y-axis and time along the x-axis, and as you can see here we have a straight line, and this line verifies Newton's law of cooling. This straight line verifies Newton's law of cooling. Now let us start the experiment. I have recorded the laboratory temperature. It is 25 degrees Celsius. Now let us have a look at the thermometer attached to this calorimeter. It is showing 60 degrees Celsius. Now I have switched on the timer here. Okay, so I will record the time taken by the water poured in this calorimeter to reduce its temperature by 2 degrees. That is, this timer will be running until the temperature falls to 58 degrees Celsius. So, the thermometer is showing 58 degrees Celsius and the time taken here is 86 seconds. Similarly, I will repeat this experiment taking the time for every 2 degree fall in temperature, and finally we'll plot the graph. So this is the tabular column, lab temperature 25 degrees Celsius, and these are the temperatures for which time was recorded. So first was the initial temperature was 60 degree and the time taken by the liquid to reduce to 58 degree was 86. Similarly, till 50 degree I have recorded the time. As you can see, the time we have to, how we have to take the time, we have to take it continuously. Between trial to trial, we are not supposed to stop the timer. It has to run continuously. Then in the next column, we have excess of temperature, that is theta minus theta naught. Theta naught is the laboratory temperature. These are the calculated values. And in the last column, we have log to the base 10 of this value. Now, let us see the graph obtained. As you can see, this is the first graph which is plotted by taking theta minus theta naught along the y-axis and time in seconds along the x-axis. This is the scale taken. In x-axis, we have taken 1 centimeter is equal to 100 seconds, and on y-axis, we have taken 1 centimeter is equal to 5 degrees Celsius. You can observe the curve here. It is an exponential curve which is called a cooling curve. And second, we have another graph here, that is log to the base 10 of theta minus theta naught versus time. As you can see, it's a straight line. The scale taken here is x-axis 1 centimeter is equal to 100 seconds and y-axis 1 centimeter is equal to 1 unit. This straight line verifies Newton's law of cooling. let us now have a look at the result. The first result is about the first graph, that is the graph of theta minus theta naught versus time is an exponential curve, and the second one, the graph of log to the base 10 theta minus theta naught versus time is a straight line, and hence Newton's law of cooling is verified. So this is all about Newton's law of cooling.